We are taking notes on more two-step equations, lesson 5, part 2 today. So you're going to notice what I'm showing you is already filled in. We're going to go to the part 2 that still needs to be filled in. Those of you in your note packet, you can open to this and turn to the next page with me. Those of you taking notes in your learning log or on paper, get your title, More Two-Step Equations. Get your learning target. I can solve more two-step equations. And then we're actually going to flip to the 2 examples that we did not do in part 1. So go ahead and pause if you need to get your paper ready. If you've got your note packet, you should be ready to go. All right, the 2 that were skipped in part 1 had a different kind of coefficient to be distributed. We call that coefficient a rational coefficient. This was lesson 3 in how we learn to work with rational coefficients. And remember, the idea with rational coefficients, in order to make it 1, is to use its reciprocal and multiply the reciprocal on both sides of the equation. In a quick review, the reciprocal is when you take that rational number and the numerator becomes the denominator and the denominator becomes the numerator. All right, so if we look at our first example, 2/3 times the quantity m plus 6 equals 10. 2/3 is our coefficient to be distributed. And what we know is in order to make that coefficient into a 1, we need to multiply both sides of the equation by that rational number's reciprocal. So the reciprocal of 2/3 is 3/2. So we're going to do 3/2 times 2/3, and then we still have the m plus 6 here in parentheses. And on the right side of the equal sign, we're going to bring that reciprocal over 3/2 and multiply that by 10/1. Remember, we make our whole numbers or integers into rational numbers by putting a 1 under it. Now, what we're going to see happen here, 3/2 times 2/3. 3 times 2 is 6. 2 times 3 is 6. So we have 6/6 times m plus 6. And on the right side, 3 times 10 is 30. 2 times 1 is 2. Now we have to simplify. 6/6 can be simplified to 1. So now we just have a 1 times m plus 6. And 30/2, 2 can go into 30 15 times. Now what you're going to notice happens is that it actually, when you distribute 1, it doesn't change what's in the parentheses. So if we rewrite this at this point, we have 1m plus 6 equals 15. We're down to a one-step equation here where we just have to zero pair our constant of positive 6. So we're going to do negative 6 on both sides. We're going to check that and make sure we have a positive and negative of that same constant, which we do. Bring down our variable term, which already has a coefficient of 1. And 15 minus 6 is 9. So I think the solution that will work is m is equal to 9 to make this true. Let's give that a check here. So when we check, our rational coefficient is back into play. That's okay. We know how to work with rationals. Remember, we do not discriminate. We're going to take that 9 and substitute it where the m is. So we have 2/3. That's a 3 there. Good. 9 plus 6. Now do the math. Do your PEMDAS. Start with the parentheses. 9 plus 6 is 15. So we have 2/3 times 15/1. All right, 2 times 15 is 30. 3 times 1 is 3. 30/3 simplifies to a whole 10. So the left side is 10, the right side is 10. Let's try one more. 3/4 times the quantity x minus 6 equals negative 12. We're not going to distribute that rational coefficient. We learned how to deal with rational coefficients, which is make them into 1. So we're going to multiply both sides of this equation by the reciprocal of 3/4, which is 4/3. Hopefully you said that before I wrote it. 4/3 times 3/4 times x minus 6. And then you take that 4/3 on the right side of the equation too, and take that whole number 12 and make it into a rational number by putting a 1 under it. 4/3 times 3/4. 4 times 3 is 12. 3 times 4 is 12. Numerator times numerator, denominator times denominator. And then we have x minus 6. On the right side, 4 times 12 is 48. 3 times 1 is 3. All right, now we need to simplify our rational numbers. 12 over 12 is the same as 1. X minus 6 in parentheses. And 48/3. Well, maybe we need to do the side math here. How many 3's go into 48? Got 1. 4 minus 3 is 1. Bring down the 8. Oh, 16. That's right. So this simplifies to 16. Should finish that math. All right, so we're going to take that over here. Distributing a 1 does not change anything, so you still have 1x minus 6 equals 16. We're going to zero pair that constant. Negative 6 becomes a positive 6 on both sides. Make sure you have that zero pair. You have a negative and a positive of the same number. Bring down your 1x. 16 plus 6 is 22. So I think if I put 22 in for x, I can get the left side to equal 12. Let's see if that's true. I have 3/4. Oop, my color didn't change. Hold on. I have 3/4 times x minus 6, and that should equal 12. All right, so I'm going to do 3/4. Oh, Mrs. Benoit, change your color. Because now I'm doing the substitution, aren't I? And I'm taking that 22 and putting it in for x. So I have 3/4 times 22 minus 6. Now I'm going to do the math. PEMDAS. 22 minus 6. Come over here and do that because there's some borrowing involved. Group of 10, that's 16. So I have 3/4 times 16 over 1. Numerator times numerator, 48. Denominator times denominator, 4. How many 4's go into 48? Well, 3 was 16. So 4 is going to be 12. My left side is 12. My right side is 12. I know that's a mess of work. But have these two examples ready to go to help us with our practice. See you soon.